In this lesson, we're going to talk about using distance for two different shapes. We're going to talk about rectangles and we're going to talk about right triangles. Before we start with our rectangle example, we do need to make sure that we remember characteristics of a rectangle. So we have two sets of parallel sides and then adjacent sides, or sides that are meeting at the vertices, need to meet at 90-degree angles. So we have to prove different information about slopes. And then the opposite sides of our rectangle also have to be equal length. So that's what we're going to do. So here is our first quadrilateral that we're going to look at. So I'm going to start by graphing this. And I'm going to label these points A, B, C, and D, just to make talking about sides and slopes of those sides easier. So here's A. Here's B. 1, 2, 3, 4, 5, 6, 7, 8, 9. -3. 3, 4, 5, 6, 7. Okay, so there's side D, or point D, I mean. And since I can't draw straight lines, let's clean this up a little bit. All right, so let's start with slopes. So I'm going to look at the side AB. I need to look at side BC. I need to look at side CD, and I need to look at side DA. So I'm going to start by finding the slopes of these lines. And I'm going to use our big triangles here only because I know that eventually I'm going to have to do distance again, like yesterday. So I'm going to attempt to draw straight lines and make our big triangles like this. That way when we go to do distance in a little bit, we'll have everything ready to go. So let's see, 1, 2, 3, 4, and 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, and 3. 5, 6, 7, 8, 9, 10, 11, 12. And 9. Okay, so just looking at the numbers that are here on our triangles that we've made, I have a lot of the same numbers, which is a good thing because that probably means in terms of slope and distance, we're going to be good. Now we do have to keep going because we have to explain our thinking and we have to prove that this is actually a rectangle. So if I'm talking about slopes for AB, the line is increasing, so it'll be up 4 over 3. So that would be a slope of 4/3. Here between B and C, I have to go down 9 and over 12. And I am going to simplify this for the slope. So 9 and 12 are both divisible by 3, so that'll be -3/4. Here, this is positive again. down 4 and over 3, so that will be 4/3. And then this is another negative slope, and it is also negative 9 over 12, which simplifies to 3/4. So in terms of the parallel sides requirement, I know that AB is parallel to CD. This sign means parallel. It's like a vertical equal sign. And I also know that BC is parallel to DA. So that meets the opposite sides being parallel requirement. Now I need to talk about perpendicular sides. So I need to look at the sides in all of our corners. So AB and BC meet here. That's a right angle. That's good. So we have AB being perpendicular to BC. This sign means perpendicular. I have BC being perpendicular to CD because it meets the opposite reciprocal with slope. These are the opposite reciprocal slopes, so that's this corner here. So I have CD being perpendicular to DA. And then last but not least, AB and DA. So I have DA being perpendicular to AB. All right, this is part of our answer. That means all the sides requirements with the angles and being parallel and perpendicular. Now we need to talk about the distance or the length of these sides. So I need to find the length of AB, of BC, of CD, and of DA. So thinking back to yesterday, I'm using Pythagorean theorem. So I'm going to label these. I'm going to do this in black so you can see it a little bit better. I'm going to label this X. I'm going to label this Y. I'm going to label this Z. And we'll just label this R. Just so that we have variables to assign here. So X squared is going to be 4 squared plus 3 squared. So ultimately, I'm going to be taking the square root of 4 squared plus 3 squared. So here my value for X is going to be 5. And I did that all in my calculator. I did not do that in my head. For BC, let's see, BC is Y. So I have Y squared is 9 squared plus 12 squared. So ultimately in my calculator, I'm doing 9 squared plus 12 squared under the square root, which is going to tell me that Y is 15. So there's 2 pieces of information. Now these are sides that are connected in a corner. They're not opposite sides. They're adjacent sides. They're next to each other. So it's okay that they're not the same length. So CD is Z. So this is 3 squared plus 4 squared, which is exactly what I put in my calculator before for AB, which is good because they are opposite sides. So one statement I can make, and I'm going to show you a little notation. This equal sign with the tilde on top, this means congruent. So I know that AB is congruent to CD. That means this side here is the same length as this side here. We're almost done. Now I have R squared is 9 squared plus 12 squared, which is exactly what I had for BC. But again, because we are proving that this is a rectangle, now we know that line BC is congruent to line DA. And this would be the second part of my saying, yes, this is in fact a rectangle. Woo! All right, so this tells me that AB and CD are parallel sides. They are also congruent. BC and DA are parallel sides, and they're also congruent. And all of my four corners are right angles. That meets all of my requirements for being a rectangle. All right, so the next one we're going to look at, we have triangle ABCD that's been given to us. And we have CD being the height. In order for CD to be the height is perpendicular to the base. So here, CD needs to be perpendicular to AB. So that's one thing that we need to double check first before we go any farther. So I'm going to connect C and D right now just so we can see it a little bit better. So finding slopes of CD, I'm going to go 1, 2, 3, 4 over 1, 2, 3. So this would be -4/3. So in order for this to be perpendicular, I need to prove that the slope of AB is +3/4. So that means I would need to be able to go up 1, 2, 3 and over 1, 2, 3, 4, which is in fact the case. So I know that this is a perpendicular line. So I know that this is true. Now that we are sure that CD is the height, we're going to do the area and we're going to do the perimeter. So let's start with area. The area of a triangle is 1/2 of the base multiplied by the height. Well, that means we're going to have to do some distance formula again. Woohoo! All right, so for A to B, we're going to have this big triangle down here. This is 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6. So for AB is the base, and CD is the height. So for line AB, I'm going to do this over here. I have 8 squared plus 6 squared. That's all under the square root. Grabbing my calculator really quick. Square root of 8 squared plus 6 squared. Now this just happens to be a perfect square because it will be the square root of 100. So this is 10. So I know my base is 10. And now I'm going to do the same thing for CD. I'm going to make this triangle in here. So I have 1, 2, 3, 4 over 3. So for CD, I have the square root of 4 squared plus 3 squared, which we did previously on our rectangle. So I know that the height is 5. So now I have everything I need for my area equation. So 10 times 5 is 50. Oops. And half of that tells me that my area is 25 square units. And it's square units because area is a two-dimensional measurement. All right, so I have area taken care of. I need to do perimeter. And for perimeter, I need everybody on the outside. So I'm going to need AB, but I'm also going to need AC and CB. So here, this is 1, and then 1, 2, 3, 4, 5, 6, 7. And then here I have 1 and 1, 2, 3, 4, 5, 6, 7 again. So this happens to be a very special case triangle where it is an isosceles triangle where these two sides are going to end up being congruent. And I know that because these two triangles we've created to find the distance are congruent triangles. So let's see, AC is the square root of 1 squared plus 7 squared, which again, I'm going to do in my calculator because it is the square root of 50, which I don't know off the top of my head. So I'm going to round. I'm going to do 2 decimal places. So this is 7.07. And because BC is the same triangle length, or excuse me, the same side lengths for the triangles, I know that these two are going to end up being the same because here I'm doing 7 squared plus 1 squared, which is exactly what I had here, which is 7.07. So our perimeter, I'm going to add up those 3 numbers that I've circled. So I have 10 plus 7.07 plus 7.07. So our perimeter is 24.14 units. And this is just units because perimeter is a one-dimensional measurement where I'm going around the outside of a triangle. So one thing we always need to make sure of when I'm being asked to find the area of a triangle is that here the height and the base are perpendicular, which I do by looking at slopes.